So this little video is going to be on nesting a for loop without actually nesting the for loop. And what do I mean by this? Well, basically, usually if you want to create a for loop, so like a nested for loop, so I make a function for it, def function, and I'll just call this nested for loop. So something like this, where we're going to create and run a nested for loop. And what does this mean? We do this quite a bit, basically for I in range, and then say for example we went for I in range 10, we then might want to inside here do for, I'll do another for I in range, but I'm going to this time change it to j because we're going to list, and we're going to for j in range I, so we're going to count up to the variable I and then stop, and we might do something like print and then I comma j. So we'll get all of our i's and all of our j's like this, and we can now remove the pass statements because we filled out both of our for loops. So that's what was running. That's like a nested for loop, and you'd see similar patterns if you did it in other languages, only that you'd have the curly braces. So the Python one's a tiny bit cleaner because it just uses the white spaces and the colons at the end of the sentence. So that's kind of like how it would run. And if what I will actually do here is in my main function, I'll comment all this out for now, and I'll actually just run that piece of code. So this is our nested for loop, and if we run this, we get something like, well, we get a combination of all of the i's and j's. So we get 1 0, 2 0, 2 1, 3. We don't get 2 2 because when we got up to j, then it continued to loop, and then we've got 3 0, 3 1, 3 2, 4 0, 4 1, 4 2, 4 3. So we always get to one number less than the first one because we're looping up to this j. But we can see here that you can do this operation, and then you can do all kinds of things, whatever you want, but effectively you're going through some kind of matrix when you're doing this. And you didn't have to have this up to I, for example, but you could have had this up to 10 as well. So if we did that, we get 100 by 100 because we get everything up to 10 and everything up to 10. So if we run that, we get this much longer thing. I think if I do view as a scrollable element, you'll kind of like see this, where I don't even know if the scrollable element will be long enough, but we go 0 0 0 1 all the way up to 9 here, and then we've got 1 0 1 and all the way up to 9 1 9 again, and so forth contiguously until we get to, it does go to the end until we get to 99. So that's what that's going to do. This one here prints something that's more triangular in shape because you're going up to j, so you're kind of like cropping yourself. So the first one, when we do this, if I run this again now, wonder why that one, I've got an unbound local error. How about that? Change that to white. Sorry, run that again. I'll just delete this bad block there because we don't need that in our face. Where we got 1 0, then 2 0, then we got our 2 2s, then we get 3 lots of 3, then we get 4 lots of 4, and 5 lots of 5, and so forth, and we'd get I guess 9 lots of 9 there. Do we get 6 lots of 6? 1 2 3 4 5 6. Here we do get 6 lots of 6. Then the little dots interfere with us, but that's because we get too much as an output. So that's just generally our nested for loop. That's what happens, and I'm just wondering if I can get it into some sort of triangular range. I don't think so without doing anything complicated. But what I do is this now. So this is our, let's just pull this up. This here is our standard pattern. If I can draw, right, my drawing function doesn't seem to be working. Let's just change my pen color. Does that work? Nope. Okay. Nope, looks like it's not working, unfortunately. Try that one more time. Let's So I'll get a pen working. No, okay, no colours today. So that's fine. That's not working. Our nested for loop, which is this, but I'll just do it by highlighting our nested for loop, which is this part here, that feeds into this nested for loop here. So that's what we got, and that's our like we got this triangular pattern that comes out here. Now I'm going to comment out this nested for loop, and this time what we're going to do is we're going to run our for loop as standard, but I'm going to call this the outer for loop. So I make this function, and we can actually see when I do the highlighting here, we're already seeing it's here because I'm replicating part of the code, which is the for I in range 10. And I'm going to call this the outer for loop like that. And what we do is we set up this array, and I've done it this way. We didn't have to, but if we do set up this array, we can capture all our data a little bit better. So we set up this array over here to capture our data. And when we step into the loop, we then go in and look for this inner loop. So we've got this inner loop that's here, and notice when I highlight it, it actually highlights this piece down below because again it's the same piece of code. This is our inner loop, but now we're one level of indentation back. So here we're down at, if I could draw a line, we'd be at 2 levels of indentation. We can see the 2 tabs across here. And now we're just one level of indentation in, and that's because we've gone back to this inner for loop pattern over here. Now, it depends on how clever or what we want to do and so forth. So we could have done a lot more stuff in here, but all of our code inside of this double nested for loop has 2 levels of indentation. So that's our first level. So in fact, it's got 3 levels of indentation because the third level of indentation is where the print statement begins. And if we're using Python and we use a standard convention for Python, which is 4 spaces, we're 12 spaces in already. So, and if we want to be reasonably Pythonic and stay within our line regions, then also we are, then we kind of like we've got 80 spaces here. So how many spaces would we have left? We'd have 80 minus 12 basically. So 80 minus 12. So we shouldn't be having like really long lines of code. At least that's kind of like some people's view on how code should be. We shouldn't have really long lines of code. And I've also seen comments that you shouldn't have like too many multiple levels of nesting. So I'm going to have one more go with the colours just to see if I can get them working. And yeah, let's have a little browse. Yeah, so we see our pattern over here. And this is our nested for loop over here, which fed into the nested for loop when we were running it over here. So it fed into that. That's what we were calling initially. So let's remove that now. What we're now doing is we've got an outer for loop, which is this component here. If I draw it, it's going to the outer for loop, and then we have an inner for loop, which is this, and it goes to our inner for loop function over here. So we will kind of like remove our nesting, and what we do is we now create an array here. So our array looks like this. At this point, I just want to pass some values back into the system. So what we actually do here is we create a dictionary, and this enables us. We don't have to do it this way, but if I do create a dictionary, then we can kind of like, we can pass this dictionary for each j in the range I, we can pass back, we can increment our dictionary and pass back this value I, and we can select return this dictionary. Now, this dictionary, which comes from the inner for loop here, goes into our results over here, and then we can append our answer list. So we're going to get a list of dictionaries. That's what we're going to get. So if I was to comment this, we're now going to get this bit here will be a list. I should really put it in. I don't know where to actually put it, but this bit here would actually be a list of dictionaries. That's effectively what we're going to get back, and so it will look something like this. So it could be one dictionary, and then it'll be the next one, which will contain some data, and then it will be the next one, which should contain more data, and so forth. And they should be growing in data as well, because we see here that the for J in range, the dictionary, when I is larger, the dictionary can get bigger because there are more items in the dictionary. Now we return a dictionary at the end of the inner loops. So we get these series of incrementing dictionaries. That's actually what's going to happen. So we can begin to run this code. And how do we run this code now? And this is a nice thing about putting things into functions. We can do this kind of thing very easily. We can do it in all languages. It's not just Python. You can do it in every language. But we can run our outer for loop, and that's all we need to do. Because if we run our outer for loop, that calls this function here. That's our outer for loop. And there's nothing else that's needed, because this outer for loop then runs this, gets to this point of code, line number 34, where it has to run the inner for loop, which is effectively running this function over here. That's constructing the dictionaries. The dictionaries get formed in their longer sequences, and we get this kind of like nice, beautiful feedback loop where the dictionaries come back into here and they feed into our answers, and they begin to populate our list, and we return this list. So we get this answer list and it gets bigger and bigger. We return this list from the outer for loop all the way back here, goes back in, and then we can print our result. So that's basically, it looks a little bit complicated, but it's actually quite nice when you get this right, because if I run this piece of code now, it looks like this down below, this little section over here. And we can see that we start off with nothing, because our first dictionary doesn't contain anything, because I equals 0 for our first element of the loop. Now we could have done it for I in range 1 to 10. You know, we could have a little bash with that, because now we can play with the numbers. But then we've got 0, 1. That's our, like, effectively our first dictionary that's actually got values. And we've got 0, 2 and 1, 2. Then we've got 0, 3, 1, 3 and 2, 3. So we can see the same building pattern. Now if we did in our thing, and this is kind of like the beauty of it, we could set this to be any arbitrary number. So we could say like n, and you know, that would be an integer. I'm not going to type it into an integer, but we can go up to n, and then we could make that one, for example, 10 now over here. So we could call it from the outer loop. But likewise over here, we don't have to go to the inner loop here. We could also go, for example, to, I guess, could we get to n there? Yes, we could. We could kind of like call n here. I can actually leave that I in here, because basically we would just pass the n in here. So we do the inner loop for I in range n, and then the inner loops would also go to n as well. So we'd have this 10 by 10 thing. So if I do run it, we get this 10 by 10 matrix. So we can do all kinds of like interesting stuff. Let's go back to I and run it again, and we can get that. But let's say, for example, that we wanted to go from 1, 2, and then 1 to our number. In fact, I wonder if I should put a start and a stop in there, which is, that might be a bit complicated, I don't know, but we could go from 1, 2, and then over here we'd have to put in 11. So then when we run it, we get this first one being populated. So rather than having nothing going in there, we've got a 0, 1, then we've got a 0, 2 and a 1, 2 and a 0, 3 and a 1, 3 and so forth. So you can see we can do all kinds of funky and very nice things with this. We could have done the same, we could achieve the same with a nested for loop. It's just that our codes would be indented one more. And I actually put this on, if I've got it here, over here, which is in my GitHub. So I've got this thing, but I asked this extra question. So if I zoom in on this Control++++ enough times, I asked this question here, which is, can this be extended to 3 levels or even n levels of indentation? The actual answer is yes, it can be. So what would be very nice is anyone who's watched this video, if you could, or like an exercise to you, if you can do it, kind of like make your own GitHub and maybe post that as a comment in the answer. Do an extension for like a third dimension. I'm going to actually attempt to do the same myself at some point, but it'd be nice to see, firstly, if anyone's watched it, hit the like button obviously, and hit the follow button as well. But if you can do a 3-dimensional or n-dimensional version, that would be interesting to see. And also, if you've got any comments, if there are better ways of doing this, or you can think of other variations of doing it, or if you think it's a bad method to do because it's now, this is much more verbose. So you might say, well, I don't want to have all of this. In order to save one level of indentation over here and kind of like the nesting, I've had to create an entire new function over here and kind of like do a whole bunch of stuff. So it swings and roundabouts with that. This type of structure probably works nicer with longer lines of code, but so this structure here is a bit more intuitive in the way that you can see where the nesting is and you can kind of like operate within the system. Here you're jumping between functions, but this does work better when you've got like bigger lines of code, and it certainly would work better if you've got multiple levels of nesting. So that's one way of avoiding multiple levels of nesting. So that's pretty much it. Yes, hit the like button. It'd be great to see, at least I'm sure like the smarter of the people will certainly get like the n level of nesting, certainly a third level of nesting. So follow, like, subscribe, all the rest of it, and thanks for watching this video.